strictly speaking, the cosmic ray should have been cut off because it produces a lot of Higgses.
Mm-hmm. Mm.
And now, on the way home from a conference in Norway where, recently, I was looking up the cosmic ray energy distribution.
Mm-hmm.
And there is a famous knee, so-called. There is an energy at which the cosmic ray intensity falls very rapidly with the energy. So the higher energy you look for the particle coming in from the outside, the fewer of them there are. And it goes down with the power 2.7 or so.
Mm-hmm.
So, but then this power gets a little bit higher when you go just above this knee. So the curve, the plot of it somehow bends downward like a knee. That's why it's called the knee, because the curve comes to look like a knee.
Okay, yeah.
And this knee is order of magnitude-wise not so far from an effective threshold for producing Higgses. You see, when you go up in these machines, one machine bigger than the other,
mm-hmm.
you only barely produce Higgses in this Tevatron in FNAL in Chicago. Because that has, as the name says, 1 TeV energy in the proton one way, and then they use actually antiprotons the other way, but that's not so important. And they produce Higgses, but only a few thousand so far after long years. So it's not so much, maybe. And it has just begun in that energy range to produce Higgses, and they have not seen a single one. But at that energy, that corresponds to the cosmic ray, not so far from the knee. So, now you see that I would claim the knee is potentially representing that God, in quotation mark, has chopped off the cosmic ray, but not completely.
Yeah.
Above the threshold for producing many Higgses. Now, I think it is understood, although not very safely, that this knee is due to that supernovae producing cosmic rays in our galaxy have difficulty in explaining cosmic rays with much higher energy than at the knee somehow. And therefore, the knee is connected with some more or less understandable production mechanism from supernovae in the galaxy.
Yes.
But cosmic rays are not so well understood yet.
No, because I'm reminded here.
But then I would just say, oh yes, but maybe our God, in quotation mark, adjusted the supernovae somehow by some parameters and the galaxy and so on to produce just up to this knee.
Yes.
And then more or less stop.
I'm reminded here about just an article that we had up on our website back in 2007, actually, that the headline of the article was Milky Way Black Hole May be a colossal particle accelerator. That the idea as well there is that at the center of our the galaxy, the Milky Way, is working like a particle accelerator, and there is it's emitting gamma rays, as you said, with the energies in the tens of trillions of electrovolts. So it in itself seems to be a kind of particle accelerator. And I guess that what you're saying there.
I think so. Yes.
Yes.
I think there are some galaxies which presumably contain black holes, much bigger perhaps than the one in our own Milky Way.
Yes.
And I think they are strongly suspected, with good reasons, for sending out cosmic rays. So I think that there are some far away galaxies that have active galactic centers, which very likely are these black holes. So they produce cosmic rays, and these ones are probably some of those that produce even the very high energy cosmic ray,
Yes.
which is above the knee, because there are some cosmic ray radiation above the knee.
Right.
So they produce the ones that do produce Higgses in a similar way as LHC or even more severe machines.
Yes, exactly.
So our God, in quotation mark, didn't switch off everything that could do it.
No. That's interesting.
But this is a black hole. That's right.
Yes.
Random dynamics.
Yes. Do you want to mention something about this here in
Yes,
closing?
I think I would like to.
Yeah, go ahead, please.
To tell that the random dynamics is a priori an attempt to make a theory of everything, as also the superstring theory is attempted to be used for.
Yes.
So it is like a competitor to the superstring theory.
Yeah.
But the random dynamics, that is characterized by some slogans of the type that almost all theories are right, or that let us think that the fundamental theory is enormously complicated, so complicated that we couldn't write it down at all. Not just like string theory, explain it well in a few books or so. No, it would be totally impossible if it was very, 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 very complicated, more complicated than that its full description would need the writing down of the whole universe or something. So, if that was the case, then we couldn't write it down because it would be too difficult to write it down, and we wouldn't have space for writing it. But we could hope for a hypothesis, which is the hypothesis of random dynamics, that almost all very complicated theories, when interpreted appropriately, would show up to give us effective laws of nature, extremely close to what we see, and that therefore we could say those laws of nature we see today, which is effectively the standard model and gravity and things like that, that we could say that these things, we can explain them by taking almost any very complicated theory or enormously complicated theory and interpreting it a little bit cleverly, which we still have to do on our website of random dynamics. And then we could say, now we got an explanation of the laws of nature we know today because they come out of almost any theory. So we don't need to know which theory it is. It is enough to know that it was not one especially stupidly chosen theory that would precisely be organized to give wrong effective laws, but if we look for the effective laws from a very random one, then we get it. So this is what lies in the word of random dynamics. You take a random theory, and then for reasons which may go back to my relative youth, I called it random dynamics, where dynamics approximately stands for a theory about the development of the world or so.
Wow. So it's a unified...
In this sense, the random dynamics is so ambitious that you could in a way beat all the other theories, such as string theory, because even if string theory did it well and gave the good agreement, then you could say with a certain right, yes, but maybe that's just one of the theories in random dynamics, and that random dynamics would be true anyway, so it doesn't matter which theory. You can't justify your theory by getting the right effective theory because you would get that from any of them. And then we would somehow show that it was stronger and more simple to assume than almost any competing theory.
That's interesting because it's what you're looking for here. Then, in one way, is the a unified field theory, pretty much. A theory that explains everything, right?
Yeah, I didn't catch the last. You said X-ray.
No, I said what you're looking for is a unified theory, one that explains everything, right? Yeah.
Yes, this